students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today, as you know, it is Sunday and today we have conducted the mock test 6 on the chapter aldehydes, ketones and carboxylic acid. So I hope all of you would have downloaded the question paper from our WhatsApp channel or from the community post and would have solved the question. So now it is time to analyze that, to check your solutions and analyze your strength in this particular chapter. So for every correct answer you need to assign +1 marks, and for wrong and unattempted questions you have to assign 0 marks. Okay, so now let's get started. And if you haven't downloaded the question paper yet, so I want, please do not watch this video without solving the question paper. So please go to the WhatsApp channel, download it, solve it, and then come back to check the solutions. Okay, so now without any further delay, let's get started with the first question here. So okay, so now the first question is the reactions between C6H5CH2 and CH3COCl leads to the formation of. So if you have remembered, in the preparation of ketones from acyl chlorides, we had the first method, that is alkyl lithium, right? Alkyl cadmium. So that is what is present here. So we have CH3COCl, okay, and then you have this one R2, that is your C6H5CH2. Okay, so I'll have C6H5CH2, cadmium. So what is happening, this Cl group will be replaced by this R group. So I'll get CH3, C double bond O, CH2, then C6H5. Okay, so now if you number it 1, 2 and 3, substituent should get the least number. So we will have 1 phenyl propane 2-ONe, 1 phenyl propane 2-ONe. So correct answer is option number B. Okay, simple question. Next, coming to this one, CH3, CH2, CH2Br with KCN. So this one will give you CH3, CH2, CH2Cn. So what is your A? A is CH3, CH2, CH2, Cn. After that, if you treat it with SnCl2, HCl and water, so if you remember, this is a name reaction, that is your Stephan reduction, right? So in that case, what will happen? We will get here CH3, CH2, CH2, CHO, that is butanol. So correct answer for this question will be option number A. Like direct name reaction questions have been asked here. Okay, next, you have Cn and then it is getting converted to CHO. So again, this is the same Stephan reduction, SnCl to HCl, water, and then boil. So correct answer is option number A. Next, the compound formed when calcium acetate and calcium formate is dry distilled. Okay, so this is an important question. Okay, so you have here calcium acetate. So I can write like this, CH3, C double bond O, Ca, and then you have CO, CH3. Okay, and for formaldehyde, calcium formate, you have H, C double bond O. One second. So we have C double bond OH and then you have C double bond OH. Okay, so when these two are reacting, then what will happen? This part is eliminated. Okay, and we get this and like 2 carbons are there, so we'll get a aldehyde of 2 carbon, that is CH3COH. Okay, so correct answer is acetaldehyde. Next, Skiff reagent is, so you should know that Skiff reagent is nothing but rosalynyl hydrochloride. Okay, next, acetone is less reactive than aldehydes because, so generally we know that ketones are less reactive than aldehydes. Now this is because of 2 reasons. So when you have ketone group, okay, so these are your C groups, right? R groups are present. Now when a nucleophile wants to react here, right, so this carbon should be what? Electrophilic should be, this carbon should be more electrophilic. Now due to these 2 carbon groups, what happens? They have plus I effect, right? So they donate the electrons here and reduce the electrophilicity. So that is one reason. And second reason is due to this CH2 alkyl groups, there is more steric hindrance. So the nucleophile do not find it easy to come and attack to this carbon, right? So that is why we need two reasons, that is the plus I effect of the alkyl groups decreases the electron deficiency of the carbonyl carbon, this statement is correct, and of the steric hindrance of the attacking nucleophile. Okay, so both B and C, so correct answer is option number D here. Okay, when formaldehyde is heated with ammonia, the product formed is. So here this question is an important question. Okay, product formed here is called as urotropine. Okay, urotropine. And what is the structure of this one? So if you draw like this, we have, this is the structure of urotropine. Okay, and you have N here, here we connect it with CH2, CH2 and then CH2, and here one CH2, here one CH2, here one CH2. So total 6 CH2 and 4 nitrogen. So correct answer for this question is option number D. Okay, next one. The correct order of reactivity of carbonyl compounds in the following compounds. Okay, so what are the groups given? First one is benzaldehyde. Okay, so I'm just drawing all the structures first. Then you have para-tolualdehyde, that means you have benzaldehyde with, at the para position you have CH3 group. Then you have para-nitrobenzaldehyde, you have next one CHO with nitro group, para-nitrobenzaldehyde, and then acetophenone, you have acetophenone. Okay, so now just now we have discussed that aldehydes are more reactive than ketones. So you can see these three options are your aldehydes, whether this is a ketone group. So definitely acetophenone will react the least, right? So where we have acetophenone least here, so obviously we can eliminate all these three options. Correct answer will be option number D. Okay, now but let us see the other questions also, like other options. One second. Okay. Okay, now coming to next one, if you see that this compound should be electron deficient, right? A nucleophile will attack, so the group should be electron deficient. So NO2 is what? It is an electron withdrawing group, so definitely it will reduce the electrophilicity of this carbon and will help in the increase in the reactivity. So para-nitrobenzaldehyde will be highest, and this one is someone which is donating the group, so it reduces the electrophilicity. So this one will be here para-tolualdehyde and then benzaldehyde. Okay, so correct answer for this question is your option number D. Okay, D. Okay, now let us see the next question. Acetaldehyde is allowed to react with excess of absolute ethylyl alcohol in the presence of dry HCl. The product formed here is. So you have acetaldehyde, that is CH3C double bond OH. Okay, and it is reacted with ethyl alcohol, excess of ethyl alcohol. So I'll write like this, C2H5OH. So this, if you remember, reactions of aldehydes and ketones with alcohols used to give us hemiacetals and acetals, right? So with excess we will get acetals. So what I'll form? CH3COC2H5, then you have OC2H5, and then you have H, right? So here what will happen? We get 1,2-diethoxyethane, right? 1,2-diethoxyethane. So correct answer is option number C. Okay. Next, a compound A has molecular formula of C2Cl3OH. It reduces swelling solution and on oxidation gives a monocarboxylic acid B. So the compound A is having a formula of C2Cl3OH, right? And on oxidation, it gives a mild monocarboxylic acid B. So on oxidation it is giving you B. Okay, now A is obtained by the action of Cl2 on ethyl alcohol. So by the action of, you have here ethyl alcohol C2H5OH, and you treat it with chlorine, we get this compound, right? So this compound, when you treat it with this one, we'll get CCl3. Okay, so CCl3.CHO. Okay, and on oxidation we get CCl3.COOH. Okay, so this compound is called as chloral. So correct answer for this question is option number A. Okay, Next, compound A, that is C5H10O, forms phenyl hydrazone. Okay, so compound A forms phenyl hydrazone and gives a negative tolerance test and iodoform test. So if it is giving negative tolerance test, that means what? It has to be an aldehyde, and it is giving you, it is not giving you iodoform test, that means there is no methyl ketone. There is no methyl ketone groups, right? And compound A on reduction gives N-pentane. So compound A is, so it has to be, first of all, it is not an aldehyde. So you can see we can eliminate this option, we can eliminate this option. Pentane 2-ONE and pentane 3-ONE. So pentane 2-ONE will give you methyl ketone, pentane 3-ONE. So this one will give you iodoform test. So this is also not the answer. So correct answer is option number C. Next, a mixture of benzaldehyde and formaldehyde on heating with aqueous NaOH gives you. So benzaldehyde is there. Okay, you have benzaldehyde, and then you have, sorry, benzaldehyde, H is to be here, and you have formaldehyde. What is the product formed here? In presence of aqueous NaOH solution. Okay, so now if you see these two undergo, like we have cross aldol condensation, similarly here we have cross Cannizzaro reaction. Okay, cross Cannizzaro reaction. Now what happens here? This OH minus has to attack either here or either here. Now if you see, this is what a benzene ring is there, so electrons will move from here to here, so this carbon electrophilicity is low. So that is why this OH will not attack on this one, rather it will attack on this one. So what we will get here, first it will give you HCO minus OH, okay, then H. Okay, so then we have in the this bond comes back, this goes here, so we get H, C double bond O, O minus, and then Na plus, you can say a salt of this one will form. So this part, the formic acid part, the formaldehyde part will give you sodium formate, and this one, this H minus which comes out here, right, this H minus attacks here and we get benzyl alcohol. So correct answer is option number A. Now, which of the following will not undergo Cannizzaro reaction on heating with alkali solution? Now, if you remember the condition for Cannizzaro reaction, there should be no alpha hydrogen, right? So, if you see here also no alpha hydrogen, but we know these two will undergo, this one will undergo. This compound does not undergo Cannizzaro reaction. Even though it doesn't have the alpha hydrogen, still it does not undergo Cannizzaro reaction because of this thing. Now, see, this is the structure like this, CCl3, you have C double bond OH, right? C double bond OH. So, now what happens? This OH minus, okay, this OH minus from your alkali solution attacks here and this bond shifts here. So, we get like this CCl3, okay, then you have O minus and OH and then H. After that what happens? This comes back and this bond cleaves here, okay. So, that is why what happens? We get here CCl3 minus and you get HC double bond O OH, right. So, there is a cleavage of this bond. So, that is why there is no Cannizzaro reaction in this particular compound, even though it does not have any alpha hydrogen. So, correct answer is option number A. Okay. Now, coming to the next question. Which of the following compounds will undergo self-aldol condensation in the presence of cold dilute alkali? So, undergoing self-aldol condensation, what we need? We need alpha hydrogen, right? So, if you see here, this compound, okay, so we have CH2, CH, CHO, C6. So, this compound has no alpha hydrogen. This one will not undergo. Now, if you see this one, this particular example, okay, so this is a triple bond here, okay. Here also no alpha hydrogen, so this one will not undergo, but this one is having alpha hydrogen. But what happens if you see this particular option, you have CH2 double bond CH, okay, then C double bond OH. Now what happens? For alpha hydrogen we need to remove this bond, but this carbon we need to remove this hydrogen, and this carbon is sp2 hybridization. So this bond, what happens? This bond is very strong, right? So removing this H and then reacting it becomes difficult. So this one also will not undergo. This one where there is sp3 carbon with alpha hydrogen, this one will go easily. So correct answer is option number D here. Okay. Next, the reaction. So we have a reaction here, C6H5CHO plus CH3CHO NaOH gives you the product. Okay, so this reaction is known as. So now you see this one is your benzaldehyde. Okay, benzaldehyde and acetaldehyde, right? They are undergoing the normal aldol condensation, but this particular reaction is given a name, that is Claisen-Smith reaction. Okay, Claisen-Smith reaction. So correct answer is option number B. Next, which of the following reagents cannot be used to distinguish between hexanal and hexanon? So this is aldehyde and this is ketone, right? So tolerance reagent we can use, this one will show, this one will not show. I2 in NaOH, so you have hexane 2ONe, this one will show. Next you have Fehling solution, again this one will show, but Br2 in CCl4 will not react with any of them. So correct answer is option number B. Okay. Next, the reagent that can distinguish benzaldehyde and propione aldehyde. So this is what? This is aldehyde, this is also aldehyde, but this is aromatic aldehyde, right? So Fehling solutions do not give test for aromatic aldehyde, so we can use Fehling solution and distinguish between them. So in that case, this one will show no reaction, this one will show reaction and will give you red precipitate. Next, oxidation of toluene with CrO3, presence of CH3CO whole 2, that is your anhydrate, gives a product A, which on treatment with aqueous NaOH produces. So if you remember, in the preparation of aldehydes, okay, in the preparation of aldehydes from hydrocarbons, under methyl benzenes we had this mechanism. So we used to get the compound like this, CHOCOCH3 whole 2, and then if you treat it with NaOH, right, so this used to give you benzaldehyde, right? So correct answer here will be option number A. Okay. Next one, CH3CN you are treating. So what is the, we have to find C here. So first of all, if you NaC2H5OH is a reducing agent, so we will get CH3, CH2, NH2, right? Now if you treat it with HNO2, that is nitric acid, that will give you CH3, CH2OH, right? After this, if you treat it with copper at 573 Kelvin, so this one will give you CH3, CH2, CHO, right? So that is your propanol. So we will get, sorry, I increase the number of carbon, it is 2 carbon, right? So we'll get CH3, CHO, CH3, CHO. So correct answer for this question is option number B. Next, an aromatic compound X with molecular formula C9H10O gives the following chemical test. It forms 2,4-DNP, okay, reduces tolerance reagent, means it should be an aldehyde group, and 2,4-DNP it can be, it is telling it is a carbonyl compound, aldehyde or ketone. Now it is confirmed that it is an aldehyde group. Undergoes Cannizzaro reaction, so that means no alpha hydrogen. On vigorous oxidation, 1,2-benzene dicarboxylic acid is obtained. So that means the substituent should be at the 1,2 position. So first of all, we want that it should be an aldehyde. So if I see this is a ketone group, so I can eliminate this option. Now if you see here, there is 1, 3, 1, here there is 1, 3, here also 1, 3. These two cannot give you because I need 1, 2. So correct answer will be option number A. Okay. Next question, you have CH3 whole 2 CO, that is your ketone group, and it is reacting with CN. So I'll get first of all CH3, C double bond O, CH3 if it is there. Next, if you are reacting it with NaCN, okay, so this one will give you CH3, CH3, then you have OH, and then you have CN. Then if you do H3O plus, we will get CH3, CCH3, and then you have OH, and then you have COOH. Okay, so we will get CH3 whole 2, COH, CN will be your N, like first part, and then CH3 whole 2, COH, COH. So correct answer will be option number A here. Okay. Next question. So this is also similar question. You have CH3 COH, then you treat it with HCN, so we will get CH3 COH H and then CN, and then when you treat it with water we get CH3 COH and COOH. Okay, so this compound is called as lactic acid. So correct answer for this question is option number C. Okay, next, which of the following compounds would have the smallest pKa? Smallest pKa means highest acidic, right? Highest acidic in nature. So you should have electron withdrawing group. So you see 1, 2, 3, 4. On the fourth carbon we have fluorine. So inductive effect decreases with distance. Let us see next one. Here on the second carbon we have 2 fluorine. Here 1, 2, and you have here on the second carbon, sorry, you have on the third carbon and you have on the fourth carbon, and here there is no electron withdrawing group. So definitely this is nearer to this one, so it can stabilize better. So correct answer is option number B. Next, the correct order of acidic strength is, so N-butyric. So let us first write down the structure, all the compounds. So this is option A, B, C, D. Okay, N-butyric acid means normal. You have CH3, CH2, CH2, COOH. Next you have 3-chloro-butyric acid. So you have 3-chloro. So 3-chloro-butyric acid. Next you have 2-chloro-butyric acid. CH3, CH2, CHCl, COOH. Next you have 1-chloro-butyric acid, right? So one second. Okay, so first one is N-butyric acid, then you have 3-chloro-butyric acid. So your butyric acid 3-chloro, then you have here 2-chloro, okay, and then you have 1-chloro. So you will get CH3, CH2, CH, Cl, COOH. Common name is written, right? So now if you see here, this one is very nearest, it will stabilize better. So 1-chloro-butyric acid will be the most acidic one, then 2-chloro, then 3-chloro, and then N-butyric acid. So correct answer is option number D here. Next, the correct order of acidity of the following compounds. Acidity. So if you see, first of all, alcohols will be more, acids will be more acidic, and out of this is a electron donating group, so it decreases the acidity. So that is why 3 will be highly acidic. So you have these two options, you can eliminate these two. After 3, 4 will come, so we can eliminate this also. Correct answer is option number A. Right, 3, 4, then if you see 2 will come because here there is an electron withdrawing group, and then 1 will come where there is no electron withdrawing group. So here what we should remember, that acids are more, carboxylic acids are more acidic than alcohols, right? Acidity order. Okay, next. So next question is again reaction. So this is your HVZ reaction. So we will get CH2Br and then COOH here. Okay, so this is your Y. Then if you treat it with KCN, we'll get CH2CN, then you have COOH, and then again if you treat it with CH2COOH, and then you have COOH. Okay, so this one will be called as your, if you remember, we have written OMS, right? Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid, right? Here there is 0, 1, 2, 3 and 4. So here there is only one CH2 group, so that is your malonic acid. Correct answer is option number D here. Next, the product of the reaction. So here if you see, this is a dehydrating agent, okay? CH3COH, this is a dehydrating agent. So what will happen? You have CH3, C double bond O, OH, and C double bond O, OH, CH3. So here there will be dehydration and we get anhydride. So that is ethanoic anhydride. Correct answer is option number C here. Next. Next again, this is your HVZ reaction, right? So what will get in the A? A will be CH3, CH, Cl COOH. Then if alcoholic KOH, what will happen? There will be dehallucination, right? So CH2H is there, so this HCl will be removed, so I'll get CH2 double bond CH COOH, right? So correct answer will be option number D here. Next, in a set of reactions, ethyl benzene yielded the product D. So what should be D? So first of all, if you see KMnO4 KOH, this is oxidation of the benzene. So B, oxidation of alkyl benzene. So B will be your COOH. Okay. After that you have bromine. So this is a meta-directing group. So bromine will come here. Okay. After that you are treating this one with, this is a carboxylic acid, and then you are treating it with an alcohol. So acids and alcohols will give you esters, right? So because of that, what we will get? An ester formation. So here there will be an formation of ester. So C double bond O, then you have C2H5, and here you have Br. So correct answer for this question will be option number A. Okay. Next, among the following which compound will react with Na2CO3 solution to give you salt and carbon dioxide? Okay. So now you see the options are like this. Alcohol, acid, and aldehydes. So first of all, the thing that you should know is reactions with Na2CO3 will show you acidic property. Okay, so reaction with Na2CO3 indicates acidic nature. Okay. So you have studied, might have studied in class 10th also, acids reacts with carbonates and bicarbonates, right? So now what happens? So that, but we know that aldehydes do not have acidic nature, so we can eliminate this option. Now this is alcohol, this is alcohol, this is also acid. Now alcohols and acid, both acids, so that it is already a weak acid. Alcohols also shows you acidic nature. But you should remember here again that alcohols are not that strong acid to react with Na2CO3. Here only carboxylic acid can react with carbonates. Okay, so correct answer for this question will be option number C. Okay, so students, these were the solutions for the 30 questions of mock test 6 that we have given you today. So I hope all of you had attempted the test, and please give scores to yourself and then comment down your scores so that we can understand what is your level of preparation. Okay, so and if you have any doubt in any other questions, please comment down. I'll definitely address it. Thank you for watching, and see you soon in the next class. Please remember your target 60 out of 60 in KCET Chemistry. Do not forget it. Work hard and all the very best for your KCET 2025 preparation.